so now we're going to talk about salt solutions. And you might say, wait, why are we talking about salts for acid bases? So far, let's look at our previous problems that we did. For example, like this guy. So far, we've just had my acid or my base dumped in some water. That's it. He's just been chilling. Because remember, an acid or a base is aqueous anyway, so he's just reacting with the water that he's in. We haven't reacted him with anybody else. So this whole time, we've just been talking about if you just have an acid, you have a base, and you want to know something about it by itself. You want to know its pH. You want to know its Ka or its Kb. And it could have been a strong acid or a strong base, but we wanted to know something about it by itself. So now we want to say, well, what if it's not by itself anymore? What if we took an acid and we reacted it to a base? Okay, so now instead of it being by itself, it's reacting together. So let's refresh this a little bit. So when we talked about this, when we first introduced acids and bases way back ago, we said if we have an acid that reacts with a base, it produces the same two things every time. It produces salt and water. Okay? Now when we said salt, remember we said it wasn't NaCl salt, it wasn't like the table salt, it was just a salt. So let's refresh ourselves what a salt is. So a salt is just an ionic compound formed in an acid-base reaction. Okay? So this is just an acid-base reaction. So this is our first reaction that we're talking about in this chapter. So I can take an acid, I can take a base, I can react them to each other, and they're going to make salt and water. So then I want to say, okay, well, what is the pH of the solution going to be at the end? If I mix these two, is the solution going to be acidic? Is it going to be basic? Is it going to be neutral? Like, what do I get when I react two things together? So we're going to talk about a few circumstances. There's 4 different options we could have, okay? The first option we're going to talk about is if the acid is strong and the base is strong, okay? This is our first one. So if it's a strong acid and a strong base. So for example, HCl is my strong acid, and NaOH is my strong base. They're going to create water, here's the water, and my salt. That's what they create. So what we want to do to be able to see what's happening is I want you to write the complete net ionic equation. So now you have to remember how to do that. So complete ionic. So that's where we take everything that is aqueous and we separate it into its ions. So if we separate HCl, we're going to get H plus AQ plus Cl minus AQ. Separate NaOH, we get Na plus AQ and OH minus AQ. Separate NaCl, we get Na plus AQ and Cl minus AQ. Water's a liquid, so it stays together. All right, so that's our complete ionic equation. Now we want to do the net. So if you remember with the net, we have to figure out who those spectator ions. So spectator is anybody that's on both sides of my arrow. So here's my arrow, somebody that's on both sides. So Na plus aqueous on both sides. Cl minus, Cl minus. Those are the only things. So after I look at what my spectators, I write what's left over. H plus aqueous. It's a really bad aqueous. Plus OH minus aqueous goes to water. That's my net ionic equation. Now, let's look at what's actually happening with this net ionic equation. So this is my net ionic equation, but it's a little different. So in my net, we said it was H plus OH minus goes to water, right? But it's all in water because this guy is aqueous and he's aqueous. And remember, if H plus is in water, it's the same thing as saying H3O plus. And if it's all in water, I have a lot of water. So I could actually write a second. So what happens is, these are the only guys that are doing anything. My Na plus and my Cl are spectators. They're reactants, they're products, they're not doing anything. So the only thing that's actually reacting together is going to be my H3O plus and my OH minus. One's going to be an acid, one's going to be a base, and that's where we get my waters. Okay? So the net products are water, because I get that from a very weak acid and a very weak base. And so weak acid, weak base ends up giving me my waters. Now, you might go, okay, so what's the pH? If the only thing I have left when it's all said and done is a bunch of water, what's the pH of water? 7. Okay? So, in general, if I have a strong acid and a strong base, they're going to react to make a salt and water. If I add equal amounts of my acid and my base, then my solution is going to be neutral. Now, if it's not equal amounts, then what happens is that it's close to neutral. Okay? But I don't want you to worry about is it not equal or is it equal or anything like that. Just know that if it's equal amounts, then it's going to be neutral, and then that's all you need to know for now. Okay? All right, so that's if it's a strong acid and a strong base. The next video, we're going to do the base is strong, the acid is weak. So another option.